Welcome to the deep dive. Today we're really getting into the weeds, doing an architectural deep dive into what you might call the nervous system of modern enterprise AI.
Yeah, it's a big topic.
It is. We're tackling that question that I think keeps a lot of security officers, compliance heads, especially in regulated industries, awake at night.
Oh, absolutely.
How do you actually deploy an autonomous AI agent?
Mhm.
One that can, execute real actions, moving money, updating patient records, configuring systems. How do you do that without sacrificing security, compliance, or, well, the whole company?
It really boils down to trust and control, doesn't it? And the source material we're digging into today, this comprehensive guide from IBM and Anthropic on agent governance, it confirms exactly that.
Right.
The shift to enterprise AI agents is not just a tech upgrade, it's a complete operational upheaval, really.
So our mission today is to kind of slice through the dense parts of that technical guide. We want to pull out the core blueprint you need to grasp this new way of working.
Yeah, the operational discipline.
Yeah.
Exactly. We'll hit the Agent Development Lifecycle, or ADLC, the security architecture you absolutely need, and the key protocols that make this work in, say, finance or healthcare.
And the core idea, the reason this is all necessary, is that old school deterministic software development, it just doesn't cut it for these non-deterministic agents.
Okay, let's park on that for a second. That non-determinism, you mentioned it's the key difference.
It absolutely is. AI agents, powered by LLMs, they're adaptive. They don't follow some fixed, predictable script like traditional code.
So, same input, potentially different output.
Exactly. You could give an agent the same query twice, and you might get two different but maybe equally valid results. That's because of the inherent variability, the stochastic reasoning involved.
Which means you can't just test it once and assume it's good forever.
Precisely. And that demands this whole new operational discipline. That's why we need the Agent Development Lifecycle, the ADLC. Okay, so let's really unpack that foundational change then. What fundamentally shifts for a company when they go from building, I don't know, a standard web app to building one of these enterprise AI agents?
Well, the change really forces a paradigm shift on multiple levels. You're moving from deterministic systems where you try to map out every single execution path to probabilistic systems.
Where the agent's decisions are dynamic, variable.
Exactly. Traditional apps are basically static once deployed. Agents, though, they're designed to be adaptive. They should evolve their behavior based on feedback loops, continuous feedback.
And you mentioned this before we started, the most profound change, maybe for the development teams themselves, the thing that really flips the script, it's moving away from being code first.
Absolutely. The focus shifts entirely. It has to become evaluation first. Think about it. In traditional software, if your code compiles, passes unit tests, integration tests, you feel pretty good, right?
Yeah, reasonably confident.
With agents, you could have technically a perfect implementation. The code is bug-free, the prompt is beautifully crafted, but the agent's actual behavior, it could still be awful, non-compliant, insecure, just wrong.
So success isn't just about the code itself anymore.
Not primarily. It's much more about systematically measuring and evidencing the agent's behavior and the business outcomes it achieves. You need rigorous evaluation frameworks, and you need them before you deploy. You're essentially shipping evidence, not just code.
Okay, the constant measurement piece, it makes me think the standard DevSecOps flow, plan, code, build, test, release, deploy, operate, monitor. It feels too slow, maybe too linear for this. How does the ADLC actually expand on that?
You're right. It builds on DevSecOps, but extends it significantly to handle that stochastic control logic. It introduces two really crucial inner loops to manage the continuous evaluation needed for these adaptive systems.
Inner loops. Okay, what's the first one?
The first is the experimentation loop.
And where does that fit? You said it's between the standard build and test phases?
Correct. This is where the continuous improvement of the agent's actual behavior happens. It's not just running basic integration tests.
So what is happening there?
It's things like generating adversarial prompts, running randomized tests of entire agent journeys, tweaking hyperparameters, doing automated prompt tuning, all based on the results coming out of systematic evaluations. It's where you're actively training the agent how to behave safely and effectively long before it touches production data.
Got it. So you're constantly refining the agent's brain, so to speak, before it gets out into the world.
Exactly.
But then once it is deployed, how do you keep optimizing it without causing chaos? There's a second loop, right? The runtime optimization loop. Does that need a human in the loop, or is it more automated?
That's the runtime optimization loop, and yeah, it's vital for making these things actually viable in an enterprise context. It's a continuous process, often largely automated. And it manages the agent's quality, and really importantly, its operational costs while it's live. It's monitoring things like token usage efficiency, latency, real-time policy adherence.
So, if an agent is being wasteful with its API calls.
Right. For instance, if it's constantly wasting expensive context tokens by trying tools it doesn't need for a task, this loop can automatically tune the system, maybe adjust the prompts or the underlying strategy to cut down those costly calls and improve efficiency.
So the ADLC really touches every phase then. Planning isn't just about features, it's about writing down in natural language what the agent should and shouldn't do, like policy for a machine.
Exactly. Defining that agentic behavior specification.
And monitoring.
Yeah.
Well, that's to track things we probably didn't even have names for a couple of years ago.
Oh, absolutely. Traditional monitoring was, is the server up? Now you have to track the accuracy of the agent's entire journeys. You need hallucination metrics measuring how often the output deviates from verified source information. You need to watch for behavioral drift, plus all the new cost and latency metrics tied to specific tool interactions and token counts. It demands much, much deeper observability inside the agent's process.
That focus on unpredictable behavior, on autonomy, it brings us right to the security question, doesn't it? The guide really emphasizes this.
It does.
Enterprises aren't just fighting human hackers anymore. Now they might be fighting their own autonomous systems or systems compromised by others. What are the really scary new risks that regulated companies need to add to their threat models now?
Well, what's really interesting and frankly a bit unnerving is the rise of autonomous decision-making risks, because the agent is designed to take action autonomously.
It can mess things up autonomously, too.
Precisely. It could potentially escalate its own privileges if compromised, leading to massive accountability gaps. But beyond just, say, malicious prompt injection, there are a couple of threats the guy highlights that really change the game.
Okay, like what?
First, autonomous attack amplification. Imagine coordinated attacks launched by multiple malicious agents working together. They could hit different systems incredibly quickly, distributed attacks moving faster than any human security team could possibly detect or mitigate.
Wow, okay, that's fast.
And second, there's agentic drift and non-compliance. This is more subtle. It's where gradual, undetected shifts in the algorithm lead the agent to slowly start violating policies or regulations over time. There's no single big failure, just the slow creep into dangerous territory.
That feels particularly insidious for regulated industries where compliance is everything. So if we accept that even a really well-trained agent might get compromised or just drift off course, what's the #1 foundational security control they recommend? The thing to stop a misbehaving agent causing a total catastrophe.
The absolute foundational control is sandboxing.
Sandboxing, okay, like putting it in a digital playpen.
Essentially, yes, but a very secure one. Think of it more like a digital containment unit. The source material is clear, run the agents, and critically the tools they use, inside tightly constrained execution environments.
How do they achieve that constraint?
Usually with modern tech like lightweight virtualization or really strict container security profiles, things like Linux or a Parmer, configured aggressively.
So it's not just a policy doc somewhere. It's actual infrastructure enforcement, a cage.
Exactly. It enforces least privilege access. You strictly limit what the agent can actually do, especially network access, file system access, to the absolute bare minimum it needs for its specific job.
So even if it gets compromised.
Its blast radius remains tightly constrained, as the guide puts it. It can maybe mess up its own little sandbox, but it can't easily break out and access the core enterprise network or sensitive databases it shouldn't touch.
That makes sense. Baseline containment.
Right. And that infrastructure isolation then needs to be paired up with strong governance controls, usually at the gateway or entry point for the agent's requests.
Okay, gateways. That leads us neatly to this protocol that kept popping up in the guide. MCP, the Model Context Protocol. Can you break down what MCP is and why it's apparently so essential for these enterprise agents?
Yeah, MCP is important. The Model Context Protocol, MCP, it's basically an open standard. Its job is to connect the AI applications, the agents, the clients to the enterprise systems, the servers, where all the secure data, the context, and the executable actions actually live.
And why is that standard connection so critical?
Because it standardizes how agents talk to tools, how they access resources, how they get prompts, and crucially, it does this in a way that is secure, controllable, and fully auditable.
So it's like a formal contract for how the agent interacts with the real world, or at least the enterprise world.
Precisely. The back-end systems, the servers, they expose tools, which are just executable actions the agent can invoke, and resources, readable data sources. And these are all defined with structured, typed schemas. No ambiguity.
And how do agents actually use these tools and resources securely?
They access them through what the guide calls the MCP gateway pattern. Think of this gateway as the central security checkpoint, the bouncer at the door.
Okay.
It acts as the single policy-enforced entry point for all agent requests. It handles the authentication, it generates the detailed audit trails you need for compliance, and it enforces critical operational policies, things like rate limiting, throttling, maybe even filtering certain types of requests.
Yeah.
Centralized control.
That centralized control point sounds absolutely vital for regulated environments.
Yeah.
Okay, so we've used the ADLC to build the agent, we've secured its execution with sandboxing, and we're managing its interactions via an MCP gateway.
Yeah.
How do companies then formally sign off that this thing is actually safe and compliant before letting it loose?
Right. That brings us to the governance. Test, certify, and catalog phase. This isn't just a final check, it's a formal process. Agents have to be certified, and then they get entered into a governed catalog.
And this catalog isn't just a list of agents, is it?
No, definitely not. It's much more. It has to meticulously document the agent's risk posture. That means detailing its specific threat model, the potential failure modes, and the mitigations in place.
What else goes in there?
It also needs the agent's policies clearly defining its boundaries, what it's authorized to do, how it handles sensitive data, and, crucially, evidence. This means direct links to the results from its evaluation suites, maybe reports from external red teaming exercises. Proof.
And for auditability, especially thinking finance or healthcare again, you absolutely need to know how an agent got to be the way it is, its history.
Absolutely. That's why the process demands rigorous experimentation, tracking, and lineage. Every single run during development and testing, every experiment, every model tweak has to capture detailed metadata.
Like what kind of metadata?
The exact prompt versions used, the specific model parameters, the versions of the tools it had access to, the configuration of its environment, everything needed for complete auditability and, importantly, replayability.
So if an auditor asks, why did you deploy version 3.1 on Tuesday?
You can point to the exact evaluation runs, the specific metrics, the evidence that justified that decision, full traceability.
Okay, this is fascinating.
Yeah.
Observability then, when the agent is actually deployed, the guide says it shifts from just asking, is the service up, to asking, is the agent right? What new things do teams really need to track in production?
Yeah, this is a big shift because identical inputs don't always yield identical outputs. That non-determinism, again, you need incredibly rich traces to have any hope of reproducibility or debugging.
So what does observability need to capture?
It has to capture the entire agentic flow. That means the full sequence of steps the agent took internally, its reasoning process, which tools it called, what the responses were, any function calls it, made the whole chain of events.
And what about the metrics themselves? Beyond the usual latency and error rates.
We need new categories. Quality metrics become critical, things like groundedness, which is, was the agent's answer actually based on the context documents it was given, or did it make stuff up? Also, test success rate, did it actually complete the job it was assigned?
And safety metrics too, I imagine.
Absolutely essential. Safety metrics like jailbreak rate, how often do attempts to bypass its safety protocols succeed, sensitive data leakage rates, policy violation rates. And crucially, the guide points out that the analytics, the insights you derive need to come from that agentic flow level.
What does that mean in practice?
It means instead of just seeing a generic error rate increase, you can pinpoint why. You get insights like, oh, the agent failed to retrieve veteran-specific information from the vector database in 15% of requests because it was using an incorrect function argument. That allows for really precise debugging, not just guessing.
Okay, this is complex, but it hangs together. Let's try and ground it with the real-world example from the guide. How did a company in a highly regulated industry actually use this ADLC framework to deploy a compliant agent?
Yeah, the guide gives the example of a large U.S. healthcare payer. They wanted to improve member support, answer questions about benefits, claims, etc., but they absolutely had to maintain strict AA compliance.
Big challenge there. What were the main hurdles?
Well, a major initial challenge was the lack of good, suitable historical call data for training and evaluation that was also IPA compliant. They couldn't just use raw past interactions.
So how did they solve that?
So they had to first define really clear KPIs and safety thresholds. Then, critically, they created extensive synthetic ground truth data, basically high quality, realistic, but importantly, fully compliant simulated interaction data. This let them rigorously measure agent behavior from day one, even without lots of real historical data.
So they essentially manufactured the compliant testing environment they needed. That sounds like a huge but critical step.
It really was. And then they fully embraced the ADLC. They replaced slow, manual testing with structured evaluations, constantly tracking task success rates against that synthetic ground truth, running automated compliance checks.
And the deployment.
They deployed a fully managed, compliant agent stack. It was optimized for low latency inference, which is important for user experience. And crucially, they implemented continuous compliance monitoring right into their observability system. It wasn't a one-time check before launch, it was ongoing validation.
And that worked.
Apparently, yes. It validated the whole framework's effectiveness for them, paving the way to deploy more high-value, high-compliance agents in the future.
Okay, so pulling this all together, what does this mean for you, the listener? We've covered a lot, but the core message seems to be that moving to enterprise AI agents, it forces a total rethink of software development.
Yeah, it's that shift from code first to evaluation first.
Right, from deterministic stability to probabilistic adaptation. And it all has to be built on this foundation of rigorous security things, like infrastructure sandboxing and standardized communication, like the Model Context Protocol.
And if you connect that to the bigger picture, this whole framework, the ADLC, it's really about finding a way to embrace the power of autonomy while ruthlessly maintaining control and auditability.
It's the structure needed to manage the inherent unpredictability.
Exactly. It's the structure that lets regulated enterprises use these amazing new capabilities without throwing trust, compliance, or security out the window. But it definitely requires serious architectural effort. It's not just plugging in an API call.
Well, thank you for walking us through that complex but really necessary architectural shift.
My pleasure. It was interesting to dissect.
So here's a final thought. This entire governance framework we've discussed, it's intensely focused on managing the risk of autonomous agents today, right? Putting them in secure sandboxes, routing them through controlled MCP gateways.
Yes, containing and controlling the known risks.
But the source material itself gives a little hint, a brief touch on future patterns. Things like interagent collaboration and adaptive learning, where agents modify their own behavior based on outcomes.
The next wave.
So what happens when these autonomous systems start managing themselves more? Maybe even adjusting the rules of their own sandboxes based on what they learn. How quickly will enterprises need to figure out how to integrate that deeper level of self-management into these governance frameworks we just spent all this time discussing? That's something for you to perhaps mull over until our next deep dive.